graders, how are you doing? We are getting into a new chapter, another chapter with really all about triangles. So we're going to be starting with bisectors of triangles. There is a lot of vocabulary. You have to study it. Like you just need to. You need to know what all these different terms are. Just like you need to know what sum or product or quadratic means. You need to know the vocabulary. So please spend some time studying that. Okay, so we're talking about bisectors and triangles today. So first of all, a perpendicular bisector. So a perpendicular bisector is a line that cuts another line in half and forms a right angle. Okay, perpendicular, right angle, bisector, cuts in half. Very well written out. The perpendicular bisector theorem says that if a point on the perpendicular bisector of a segment, okay, so when I look at this picture, my segment is AB, my perpendicular bisector is CD. It says if there is a point on the perpendicular bisector, then it is equidistant from the endpoints. Okay, so meaning that AC and CB are the same. Okay, that's what we're meaning. The converse flips that around. If these two sides, so from the point on the perpendicular bisector to the endpoint, if those are equidistant, then we can say that CE is the perpendicular bisector of AB. All right, so understanding the difference between the bisector theorem and the converse of the perpendicular bisector. So when we're looking at these two examples, and again, pause the video if you need to go through that. So when we go through and I look at solving this, if I know that CD forms a right angle and cuts AB in half, then I can state that BC is also 8.5 units. When I look at PQ, again, if I know that SQ is the perpendicular bisector to PR, then we can state that PQ is congruent to RQ. So we can set up the equation 3x plus 1 is equal to 5x minus 3. So 2x equals 4, x equals 2. Now, the question is asking us to find the measurement of PQ. So now I need to substitute 2 in for x. So 3 times 2 plus 1 is 7 units. Okay, so that's using the perpendicular bisector theorem. Now, we're going to get into point of concurrency. This is brand new. Again, new terminology, you need to practice it. So points of concurrency is where you have 3 or more points meet. It's where they intersect, okay? So the circumcenter, that's a new vocabulary word that needs to be put on a note card along with point of concurrency, is the point of concurrency for the perpendicular bisector. So we're going to talk about different points of concurrency in triangles. And so we need to know that the circumcenter is the point of concurrency for perpendicular bisectors. Okay. And again, perpendicular bisectors bisect, cut in half a side, and is perpendicular to it. The circumcenter theorem says that the perpendicular bisectors of a triangle intersect at a point called the circumcenter. And here's the big piece, it is equidistant from the vertices of the triangle. Now, you need to know all of that about the point of concurrency for perpendicular bisectors, because we're going to be asking you to solve algebraic equations, and you need to know those relationships. You need to know that the perpendicular bisectors meet at the circumcenter and that they're equidistant from the vertices of the triangle. It's a lot. We just need to practice, right? It's brand new. We got to practice. We got to practice. We got to practice. when you look at the circumcenter, the points of concurrency can be inside the triangle, on the triangle, or outside the triangle. So it all depends on what the triangle is, whether it's obtuse or acute or right or whatever, the dimensions of it. So that can lead into any of them. And it will still be equidistant from all the vertices of that triangle. Okay. Angle bisectors. Okay. So angle bisectors are, it's a ray that cuts an angle in half. That's an angle bisector. So the angle bisector theorem states that if you have an angle bisector, it is equidistant from the sides of the angle. And when you go equidistant, when we're talking about distance, it has to be at where it forms a right angle. It needs to be from where it forms a right angle. So I couldn't draw like a line here and say that it's equidistant. It has to be perpendicular to the end of the ray. Okay. So the angle bisector theorem says if a point on the bisector of an angle, then it is equidistant from the sides. The converse says if it's equidistant from the sides, then it lies on the angle bisector. Understanding what those are. So when I take a look at angle bisectors, okay, we need to find DB. So AD is a bisector. So these are all bisectors. So what do we know? We know that BD is 5 because it's equidistant. When I want to find the measurement of WYZ, if it's an angle bisector, it's cutting that angle in half. It has to have the same measurement as angle XYW. Looking at QS, again, we know it's an angle bisector. We're looking here to see that as well. This tells me that those two angles are the same. If that's an angle bisector, the theorem says that QS should be equidistant to SR. So 4x minus 1 is 3x plus 2, so x equals 3. Now, the question said find the measurement of QS. So 4 times 3 minus 1 is 11. Okay. Next one, incenter. Incenter. The incenter is the center of a circle that intersects each of the sides of the triangle at one point. Okay, so it's the angle bisectors. The incenter is the point of concurrency for angle bisectors. Okay, it is for angle bisectors. It's the point of concurrency. Now, the incenter theorem tells us that the incenter is equidistant from the sides of the triangle. So if we think circumcenter was the point of the concurrency for the perpendicular bisectors, that was equidistant from the vertices. Here we have angle bisectors. That point of concurrency is called the incenter, and that is equidistant from the sides. Drawing those connections back and forth is helpful. So the incenter theorem says that the point of concurrency for the angle bisectors is the incenter, and that the incenter is equidistant from the sides. And notice we have to have it equal or have a right angle. It needs to have a right angle. So the incenter, let's do a little bit of practice with this, okay? So find ST. Okay, so we want to find ST if S is the incenter. Okay, now we know that ST and US and SR are all equidistant. It might not look like it, they're all equidistant. All right, so when I look at this, I happen to see that I have a right angle hanging out over here. And I know when I have a right angle that I can use Pythagorean's theorem. Look at that, coming back from earlier this year. We're pulling it right back to solve for US. So I can say that 10 squared is equal to 8 squared plus x squared. 100 is equal to 64 plus x squared. 36 equals x squared. X equals 6. So if US is 6, then TS is also 6. Okay. Let's do one more. If the measurement of SPU, if S is the incenter of MNP, okay, so we've got to find S, we got to find this measurement, SPU. SPU, right here. We got to find that measurement, okay? Well, I have a triangle. And so I know that these are all bisectors. So I have 28 and 28 up here. And I have 31 and 31 right here. So 28 times 2 plus 31 times 2 plus 2 times x equals 180 degrees. 56 plus 62 plus 2x is 180. So 2x is equal to 180 minus 56 minus 62. So that's 118. So 180 minus 118 is going to be 62. So x is going to be equal to 31 degrees. Did I do that math right? Let me double check. Is 180 minus 56 minus 62. 180 minus 56 minus 62. Yep, so it's going to be 31 to 31. Okay, so lots of vocabulary. Practice it, study it, practice it, study it, practice it, study it. That's all I can keep saying. Till next time.